In this lesson, we will examine stoichiometry and solution chemistry, gravimetric analysis, and titrations. Gravimetric analysis is simply an analytical technique that's based on the measurement of mass. So it's an experimental technique. And what's going to be important that you know in order to do gravimetric analysis are your solubility rules. Because what you're going to see is the reactions that you study often involve the formation of a precipitate, and you'll need to use the solubility rules to identify the formation of the precipitate so that you know what substance will be a solid in your experiment. Now, the process of stoichiometry is the same as it's always been. As you have seen already, we can combine using mass quantities or gas data in order to follow the flow of stoichiometry. Now that we have a new relationship of concentration and volume that can be used to identify the quantity of moles in a particular solution, we can use that data in order to do stoichiometry. So this flow chart will look familiar, although when we first learned stoichiometry, we simply said that we have the mass of quantity A, and we're using that to find the mass of quantity B. This time, we're just going to use the word quantity because we can be given information like their mass or their concentration and volume, and when we can be asked to find their mass or their concentration, for example. The steps are going to be the same. The first step is always to use the data that we're given to find the moles. The formula that we use in order to find the moles of our initial substance depends on what we're given. Once we've got the moles of one substance, to find the moles of any other substance in the balanced equation, as you know, we use the mole ratio identified by the coefficients in the balanced chemical equation. The third step, calculating the quantity that we're asked for, we'll use the moles and we'll use the other data in the question in order to calculate what we need to. Let's do some practice. In this first example, we want to know how many grams of zinc chloride will be produced when 1.05 liters of a 2 molar hydrochloric acid solution reacts with zinc in the reaction below. So we're given a volume of 1.05 liters of hydrochloric acid, and we've got a concentration of 2 mole per liter, or 2 molar. So this is our quantity A. We know how much hydrochloric acid we have, and we're being asked to find out the mass of the zinc chloride that is produced in this experiment. So the first step is to find the moles of our hydrochloric acid. So to find the moles of our hydrochloric acid, because we're given the concentration and the volume, we're going to do C times V. Our volume is given in liters, so we don't need to make a conversion here. So we've got 2 times 1.05, which gives us a quantity of moles of 2.01. So we've got 2.01 moles of hydrochloric acid that have reacted. In our second step, we need to use the mole ratio to figure out how much zinc chloride is produced in this reaction. It's a 2-to-1 ratio, so that means that the moles of zinc chloride is going to be half the moles of hydrochloric acid that we used in the experiment. So therefore, we will be able to produce 1.05 moles of zinc chloride. In our third step, we need to find the quantity we're asked for. So in this case, we're being asked for the mass of the zinc chloride, which, as you know, the formula is moles times molar mass. So we're going to take the moles and we're going to multiply by the molar mass of zinc chloride, which is 136.29. When we multiply this, we get 140 grams reported to the correct number of significant digits.